Okay, so the most common use of the sort of oligopoly theory that we did in last class is for competition policy. And basically, competition policy is a set of tools that are, ooh, shoot. Sorry, I've got to take this. Hi, Dad, I'm in class, but what's up? I can talk for 1 second. Okay, bye, Dad. My dad's in town. Prashank, you got your exam? Okay, so in particular, I'll focus today mostly on merger policy, which is the fact that if two companies want to merge and become one company, they need to be approved by the government. And I was somewhat involved in the design of the new standards that are used for evaluating mergers in the United States and the United Kingdom. But first, I'm going to discuss some of the arguments in favor of and against such policies. And we'll start with the classic argument used in favor, which is Cournot's theorem. And then I'll talk about the empirical analog of that, which was the study by Bresnahan and Race in 1991. I'll then talk about consumer heterogeneity and some of the downsides of competition. Then I'll talk about some of the broader pros and cons of competition policy and the infrastructure around the world of antitrust policy. Then I'll turn to merger policy and practice, in particular the reforms that were made in recent years that I was involved with, and some of the most recent advances in both the empirics and theory of merger policy. Okay, so competition is, as we'll see, not always totally a good thing, but I want to start in a world where competition is beneficial so we can see the original case for competition policy. So remember that in Cournot's model, theta is equal to 1 over n. So as n goes to infinity, theta goes to 0, right? And therefore, we'll get marginal cost pricing as the number of firms gets large, right? OK. So as the number of competing firms grows arbitrarily large, price converges to marginal cost. This is one of the most fundamental results in economics, probably the most fundamental result in industrial organization. It's the foundation of perfect competition and the basis of much of antitrust policy. Now, mechanically, mergers decrease the number of firms, and that's sort of the most basic case that's made for competition policy, is that it helps to reduce theta and therefore drive prices closer to marginal cost. Now, remember that in other models, theta is determined by other factors, right? But mergers are always going to raise theta. So in Nash and Price's competition with differentiated products, the theta was 1 minus the aggregate diversion ratio, right? What that implies is that competition policy should try to the extent that it's possible, reduce sort of unnecessary branding of products that makes them less good substitutes for one another, because that tends to increase the value of theta, right? Also, if firms merge, right, then that is going to decrease the aggregate diversion ratio, right? Because the fraction of my goods that go to one of the other firms, right, is now going to be smaller because I've absorbed one of those products into my firm, right? Okay. Collusion and conjectures are another source of market power, right? That's another reason that theta can get elevated. And this is why competition policy often tries to inhibit communication among firms, tries to avoid firms being too symmetric, and tries to have laws that make it difficult otherwise for firms to collude. Another source of market power that we talked about was the fact that it's hard to search for the lowest prices. So by making more prices transparent to consumers, and this is often what consumer protection authorities, which work closely with competition authorities, often do, this can also help to reduce the value of theta. if firms have heterogeneous costs, right, then it's the second lowest cost firm who determines the price of the lowest cost firm, right? And so encouraging entry can make that second lowest cost closer to the first lowest cost and thereby effectively reduce theta as well. So basically, competition policy is all about finding in different models what affects theta and trying to do things that reduce it. Okay. So empirical studies try to look at how the number of firms or some of these other factors affect the level of markups and thereby determine the extent to which in practice, and not just in some particular model, theta actually responds to various interventions. So in particular, a paper, very famous paper by Bresnahan and Race found a clever way to study the effect of the number of firms on prices. So they noticed that as a market grows larger, it can support more firms, right? So like in a bigger town, you're likely to have more doctors than in a smaller town. And so they wrote a particular formula for this. They said, let's say that the number of people that's needed to support n firms is capital S sub n. And then little s sub n is that divided by n. So what that's basically saying is how many firms, what fraction of the population is served by a given firm as a function of the number of people. So if S sub n is constant in n, except for some little fluctuations, that would basically say that the number of people that an average firm is serving stays constant as the population gets larger. And that would be the case if the firm's markups stay the same as the population gets larger, right? Because that would, imagine that people have a fixed cost of being in a market. The profit they'd have to generate would then, the markup that they'd have to get would be constant if the number of people that they were serving was basically constant, right? So on the other hand, if as the number of firms increases, they're competing more and therefore prices is falling, you would expect to need more people in order to bring in the second firm than in order to bring in the first firm, right? So you would expect S sub 3 to be smaller than S sub 2 and S sub 2 to be smaller than S sub 1 and so forth. Is that right? Would it be larger? I think it's larger, no?
Big S is certainly larger, but while you're holding n fixed.
No, as n increase to support, oh, this is the number of people per firm. Yeah. Sorry, not per population. Yeah, so this is the number of people per firm. And if prices are falling, that should be growing as the number of firms grow, right?
Wait, the number of people per firm should be growing?
If the prices are falling, if they're going to be able to offset the fixed costs of being in the industry, right? So like the total profits you make is the number of people you have per firm multiplied by the markup that you get. If the markup falls, the number of people is going to have to rise in order for you to support more firms, right? So this thing should be increasing. So S3 should be greater than S2, should be greater than S1, right? Now, that could fail to be the case even if markups are falling because of heterogeneity. Like the first firms might find it easier to get into the industry than the later firms, or the later firms. But imagine that they all have the same fixed cost. Then we should expect S3 to be greater than S2, greater than S1, right?
Wait,
So this,
no, but aren't those the people per firm, right? So shouldn't each one be the same to like similar to compensate for the firm's fixed costs? 'Cause each firm has the same fixed costs, right?
yeah, this is the people per firm, but the point is that if when there are more firms, markups are lower, right?
Oh, okay.
Daiichi, this is your example. Yeah, if the markups are falling, then you're going to have more people to compensate for those lower markups, right? Okay, so what Bresnahan and Race did is they got data from a huge number of small towns in the United States from the Yellow Pages. And they got the populations of the town and how many people in various professions they had. So they basically found, like, how many doctors are there in their town, how many accountants, how many lawyers, et cetera, et cetera. And they were trying to figure out, when does this S value start to level out, right? S should level out at some constant once markups have fallen to the level that competition will drive them down to, right? And they found that this happened around 3 to 5 professionals. So this is S sub 5 divided by S sub n as n changes. So S sub 5 is sort of like once it's gotten pretty competitive, and S sub n is at this level. So you see that when S sub n is relatively small in the small towns, you should expect this to be high. That means that markups are effectively high, right? And what they found is that this pretty much leveled out once you got to 3 firms, that there was very little happening between 3 and 5 firms, and it almost totally leveled out by 5 firms. So the professions they looked at were druggists, tire dealers, doctors, dentists, and plumbers. Okay. So this indicates that competition has a big effect, but it mostly happens when there are a small number of firms. It's not true, as Bertrand would have predicted, that it all happens from just introducing the second firm into the industry, but it's also not true that it's like a gradual 1/n process. Most happens by once you have 3 firms. Okay. So far I've been making the classic case of why competition is a good thing. But obviously this is not going to be true when the externalities across firms are real rather than purely pecuniary, right? Now we studied that a little bit in the last lecture. We said that there could be a firm who actually has too high production, and you would actually want them to collude with another firm. But another context in which this happens even with symmetric firms was the issue of like selection and free entry that we were talking about in an earlier class, right? So now I want to try putting this into an oligopoly model. So let's imagine that each firm gets some representative sample of all the people who are currently in the market, right? So then the profits that a firm would earn are going to be the price, which depends on the total industry quantity, times the number of people that that firm serves, times the quantity of the industry, sorry, minus their personal quantity, not the total quantity of the industry, minus the expected cost of anyone who's buying the product right now, right? So then we can define average cost and marginal cost, right? And the first order condition that we can derive from this has a very simple structure. So remember, before we had price minus marginal cost is equal to theta over epsilon. But now here, it's going to be price minus the theta 1 minus theta weighted average of marginal cost and average cost.